Hello, friends. Thanks for tuning into part 3 of this mini series that focuses on Luminaire level lighting controls and supporting market research from 2021. My name is John Wilson, and in this video, I'll be highlighting some of the common sources of confusion that we identified during just the mini conversations I got to have over the course of this market research with just all sorts of people. And to be clear, in this video, I'm not trying to come in and be the authoritative source that's answering, saying what's what. What I do want to do is highlight areas where there is just reliably confusion so that when these topics come up, we can speak to them more deliberately and we can, be more aligned in what we're trying to get done, because we're all trying to turn the wheels of industry, and confusion when we're talking to each other is slows those wheels. So without further ado, let's jump right into it. There's some fun stuff in here. The first thing I want to talk about is when we started this series, I told you guys all the way back in part 1, I was introducing, what is Luminaire level lighting controls? And I said, there are 2 areas where there's just going to be, you'll commonly find confusion out there, and it's almost predictable, the 2 fault lines. And these are just how integrated does the system have to be truly LLLC. And the second reliable sort of fault point that you'll run into is just how networked does LLLC have to be, right? What do we mean by that? So that first one I mentioned, just how integrated, I'm going to kind of pass over this. I don't want to make it the focus for this conversation we're having here, largely because I think this is something that is resolving itself with the passage of time as technology gets smaller and better, and just it integrates more seamlessly, and it's available in across a broader range of products. So I acknowledge it as a pain point, and I understand why there's some confusion about it. It's just not really that, we can't do much about it in this little conversation, but we can address the second thing I want to talk about, which is the ambiguities of networked and LLLC. And to talk about this, we're going to do a little thought exercise. So we have Camp A, and people in Camp A say, look, what makes LLLC has nothing to do with being networked. Okay, so these are folks who are like, they're thinking about, they think of LLLC as this is standalone controls embedded in a fixture, right? And then you're like, yeah, that's every fixture has got, Luminaire has a photo sensor and a motion detecting sensor. Every fixture has it. Boom, that's Luminaire level, done. Okay. In Camp B, we have people who are like, oh yeah, it's maybe networked, it's networked-ish, we'll call it, right? They say it's networked-ish. We're going to come back to this one, so that's why I'm being a little glib with it. And in Camp C, this is the position I started from. I said LLLC is always networked. End of story. Okay. So we have defined it as Camp C, which is common. Folks typically, I'm from the utility world. When I think about Luminaire level lighting controls, I always think of it, or I should say this is my starting point, that I always think of it as a fully networkable lighting solution. Okay, so if the bookends here are pretty clear, like at least what the intent of what we're talking about is, right? Camp A is it's not networked at all, and Camp C is it's always networked. What are we talking about here in the middle? This is the one I want to explore a little more, because this is the one that I actually think is the most interesting, and where I think there's the most, I don't even know if confusion is the right word, because everybody agrees on what's happening. We just don't have the same words for it. So here's what's going on. I like to describe this as room-based systems and the networked schism. Okay, so the question is, if you can only talk to a device right next to you, are you really networked, right? That's the question. And some people say no. They're like, these devices may be connected at the room level, but they aren't networked. They're more like walkie-talkies, right? And then we have this other group of people who say, yeah, they are networked, if only at the room or device level, okay? And I bet you if we had like 100 people in a room and we put this out there, it would be almost 50-50 split what people would pick, Okay. Now, just supreme neutral arbitrator that I am, I'm going to say it's a room-based networked system. Okay. I would call this networked-ish. But to have this conversation in a slightly more informed way, I want to pivot us to the next slide so that we can keep talking about this. All right. So if we want to talk about room-based systems versus their more capable cousins, I want to do it in this broader context. So in the process of documenting the approaches used by like 24 different lighting, network lighting control systems, I came up with the following diagram, which represents the evolution of lighting controls in terms of networking ability, system capabilities, and also hardware requirements. Okay, so if we're wading in from the shallow end, which is where we should, we're all familiar with standalone controls. I referenced these earlier, right? And just to be super explicit, it's like those are non-networked. Okay, nothing controversial about that. Okay, and then at some point we get like our first branch off standalone controls, and so now we have these room-based systems that are, many of them are now available. They're wireless and they can communicate with each other. And that's where I asked that question, right? Like, well, just because you can communicate within a room, are you really networked, right? And I said those are sort of networked-ish. And then if we drop down to number 3 here, all we're doing, I mean, in general terms, is we're adding a hardware device, okay? And to put a name on it, we're adding a gateway, because most systems are actually scalable. It's, we used to see these would be like 2 different product lines, but increasingly it's the same system that can scale to a couple of different tiers. And the difference between number 2 and number 3 here, in most instances, it is this piece of hardware called a gateway. Has a lot of different names. We're going to talk about that more in a couple slides, but that's the only difference between 2 and 3 here. And before we deep dive on that difference, I want to finish out this diagram, and I want to make a really important caveat just to cover all my angles. To finish out this diagram, number 4, we have network systems with gateways plus some sort of additional server. And this is when we get into like IoT capable systems. Okay, so we understand these are distinct from systems that are networked with a gateway, but don't have beaconing and all these extra cool IoT solutions out there, right? So that's number 4. So right now in our evolution of network lighting controls, this is what we're looking at. But keen observers have no doubt picked up that it says till about 2018. And those keen observers, no doubt, have also recognized that what is missing from this diagram is mesh networks, right? And the reason why I've left those out at this point is because I'm leading you guys in. We're telling the story. I promise in the next video, we're going to get to mesh and all the stuff that it does that is so awesome. But to really help us understand that, I want to talk about this dynamic, and I want to talk about gateways without mesh being in the picture, so we really understand why it's so important. So I promise you, we'll get to mesh, and if you're a manufacturer and you're like, you're listening to me talk about these systems and their limited capabilities, and you're like, yeah, but my system isn't limited, I promise we'll get there. All right, here we go. When we talk about conventional room-based systems, that was like number 2 on our old evolutionary chart. Those systems, I don't care the brand, I don't care the manufacturer, they are reliably restricted to the same capabilities that you see right here and the same configuration methods, okay? So a conventional room-based system, there might have been some differences on the margins, but they're all doing the exact same thing. And it's not until you add a gateway that you're able to expand the network beyond the room and also enable these additional capabilities and configuration methods. All right, so it's like you want scheduling, or you want demand response, you're going to need a gateway for that. And if you want to set your system up with an app-based device, which, as we talked about in video number 2, is one of the most critical things, you know, offering not just for the contractor, but for the people who are going to own and operate the system. If everyone's going to have a good experience, it's really pivotal. You have like a good app-based device. Well, it used to be that the only way to get that was by also having the gateway. Okay, so it was kind of simple the way it used to work. You were a room-based system, you didn't have a gateway, then you added the gateway, you expanded the network, and you got these additional capabilities, and you got these additional methods for configuration. Okay. It's a bridge, it's a hub, it's probably the gateway, folks. Now, in the parlance of lighting, okay, a gateway is a hardware device that connects 2 networks with different protocols. Okay, this is really the key thing. The definitions are longer and they're really varied. You will find a dozen plus definitions. I mean, probably like 3 dozen definitions of exactly what a gateway is. And that's because they are very, very multifunctional networking tools that are capable of doing all sorts of stuff. That's actually one of the reasons, it's one of the underlying reasons I believe that there's confusion about what a gateway is. Okay, so to bring it back to our world, in the context of a network lighting system, the gateway is connecting and translating between 2 different networks that commonly are speaking 2 different languages. Okay, so it could be like from your building's Wi-Fi out to the internet, could be an example, or it could be from your phone's Bluetooth to the whatever low energy protocol the lighting network itself is on. Okay, and I referenced earlier, I said gateways are very multi-purpose devices, so they commonly act as you know, an API or routers or hubs or firewalls. They commonly include many of those things in one device. Gateways you already know and already love are like your wireless router at home and the ubiquitous smartphone, right? You got a gateway in your pocket. How about that? Now, this is not meant to be a, you know, class with CEUs for networking types out there. For clarity, I'm just going to throw this out because I think it's helpful. When I talk about a bridge, which will likely come up later, bridges connect 2 networks that are using the same protocol. And that's kind of the key distinction. Whereas I said gateways aren't just connecting networks, they're translating between them. So I said we're going to get to mesh. When we get to mesh, we'll likely talk about how, you know, in buildings with mesh networks, bridges are helping expand the network throughout the building, and you don't need a gateway, but just put that back in your pocket for now. Gateways. Here's the funny thing about gateways. I call this the industry obfuscation of gateways. And I want to be clear. I don't think industry is doing this out of like any nefarious, like we're trying to sow discord and confusion in the market, but make no mistake about it. Obfuscation is not good for the market, and obfuscating they are. Okay, so here's what's going on. Gateway has become a trigger word in the like broader cyber networked community that ostensibly implies either some, you know, an increased level of cybersecurity threats, and at like the very least, additional system complexity. Okay, so how has industry responded to that? Well, the first major trend that I see looking across the market is they have responded by marketing their systems as gateway lists. All right, so this is real text from real websites, and it'll be like patented no gateway architecture, no IT, no gateways, no wiring. When what they should be saying is something like, hey, no gateway required if you just want the most basic system we got. But as soon as you want to scale up and add additional features, guess what, pal? You're going to need a gateway. And ironically, I think a lot of people would actually support the statement that says, starting with a really basic system that's not secure and then adding a gateway and trying to make it secure is a way worse approach than just starting with a secure system out of the gate. No pun intended. All right, so that's the first way that industry is responding. And then the second way that they respond is they frequently refer to their device by anything other than a gateway, right? So you'll hear them called a hub or a WAC or a bridge or a router. And I'm not going to be the definitive source that's like, you can't call it that, because I think some of these in spirit are being used appropriately. But it also causes a lot of confusion, and that's what we're highlighting in this presentation. All right. Next one, another common source of confusion. I am just going to use the phrase load controller when describing the thing that controls the load, okay? Now, we're all experienced with these. We know that there's like, probably you can think of even more names for these little devices. Some of these make sense in the like hierarchical lens, right? Like there's like a fixture load controller, and then a zone load controller, and then up to a room load controller. And then we have like down at the bottom, what essentially is the Kleenex brand of Kleenexes. And it's always funny when I hear people just using this for the common, phrase out there. So load controllers, what are the sources of confusion of load controllers besides, having all these different names? Well, I think if you're watching this, you probably have a really good sense already of, the critical things a load controller does in a lighting system. I have them listed up here because I want to highlight the two specific areas where I find folks reliably get tripped up. And we're just going to talk about them high level. And then if you still got questions, or you think I'm an idiot, you can just like ping me on the side, because we got to keep all this moving, right? So that first one, embedded logic. I mean, just to be clear, we're talking about a microprocessor and some memory here. And more across the board, the trend is you're seeing logic, distributed logic, go into everything. That's why it's getting distributed. So it's logic into the load controllers. It's logic into the sensor, all right? Or even into a wireless wall station. And so not only does this make these devices more capable and in essence smarter, it also has the added benefit of making them programmable, right? We're able to program them to tell them what to do. And maybe most importantly, it leads to this other outcome that was referenced in the definition I gave of Luminaire level lighting controls, when I said it needs to have controls persistence. And having embedded logic in these devices is really what allows that to happen. So when I say controls persistence, here's what I'm talking about. Here's the scenario, okay? New building, works great, right? It's like, oh, nice network, it'd be a shame if something happened to it. It's like it works good, but then 2 years later, the gateway conks out. And then the system, the room, the components in the room are no longer communicating with that gateway. Well, if you don't have embedded logic and devices in the room, then that means, the system performing in your room, it's no longer going to have all those parameters that were put in there, not just for energy code, but like for safety and occupancy comfort and all this other stuff going on, right? But with controls persistence, if the system loses connection with that next higher network level, it still knows what it's doing. It's like, I still know what I'm supposed to do. I'm a complete, component. I'm independent, right? They're independent and capable of acting without that direct connection. So that's what we're talking about when we say controls persistence. It's important not just for the energy savings, it's really important for, occupancy, comfort and safety, and just all of the above. So that was distributed, the embedded logic side of it. Now I want to talk about the other one that came up when I was talking about people tend to get people tend to get confused between the difference. They'll conflate these a lot between the communication protocols between devices and the load controller and the control method itself, right? Like seen here, we're talking about 0 to 10. And when I talk about this, I like to frame this up like, imagine you are talking to an IT or a facilities professional, okay? Like lighting, they're lighting adjacent in their professional career, maybe, right? But they're not a lighting nerd, like so many lighting people love to refer to themselves as. Imagine them asking this question, you know, exactly what is controlling what, right? From a network level and at a hardware level, can you answer that question? And the reason that's such a great question is it forces you to sort of spell it out. And this helps us become familiar and untangle these things, right? So as we see in the diagram here, we got these wireless protocols communicating between the devices and the load controller. The 0 to 10 volt is the control method that the load controller in this case is using to control the driver, which is, operating the load here, right? Then if we add additional network hardware, gateways, bridges, routers, that is how we are then talking from the load controller, or it could be a sensor, just to be fair, to other systems, right? Like integrating with HVAC or talking to the outside world. And just to cover all the angles here, because I think this is just one extra layer of confusion that comes up. When we're talking about Dolly integrates. You see the driver is integrated with the load controller, and you have this digital two-way communication between the device and the integrated Dolly load controller and driver. So I'm a very visual person. I think most of us are. I think graphs like this, diagrams like this are exceptionally helpful for helping us just understand what the system is doing and lay it out there. So hopefully we can answer very reasonable questions like exactly what is controlling what and how. All right. Thank you so much for sticking around for this part 3. It's like time sure flies when you're having fun, right? If you have questions, comments, find me on LinkedIn, reach out to me in the contact info I've got listed right there. And please, folks, stick around for part 4. It is going to be the finale. It's the crescendo. It's going to be a lot of fun. As always, I'm John Wilson with Fernhill Shopworks. Thanks so much for checking this out, and we'll see you hopefully part 4.